So the last thing that we want to do is we want to do the entrainment experiment with Lagrangian particles. Let me just quickly explain what's the difference between particles and Eulerian tracer. So Eulerian tracer is you work out the concentration at grid cells. Okay, and the information, like the value, is passed on between adjacent grid cells. So convection and there's diffusion. It's the main mechanism. Okay? With particles, the only thing that you actually record is the change of the location. The particle can cross grid cells and you work out the new locations, predict the locations of. But you can do a similar experiment here in this example, something like 1,000 floats initiated near in the lowermost 20 meters of the water column, and then again you start this convection experiment and you work out where do the water these particles. And we call them non-buoyant particles because they don't have a weight relative to the ambient fluid. Not like sediment that can sink. You can add sediment behavior to these floats if you want to do some scientific. But this is not done. Yeah? Let's have a look at the simulation. Okay, you can see the entrainment of particles. Well, for example, if these are plankton spores that sit near the seafloor and hang on there over most of the stratified time, and you get these convection events, you can lift them towards the surface and mix them. So there are some applications of these particles. Or if you imagine again that you have some nutrients affiliated with. All right, this is the convection. I always get excited because this is actually what I studied in most of my PhD.